everyone, it's Judy here again, and today we're looking at experiment 2 in Chemistry 1100, which is entitled Chemical Changes and Identification of a Substance. So we're going to start with looking at chemical changes here in this first video. So the main goal of this part of the experiment is to show you the difference between an observation and a deduction. So an observation in a chemistry lab is exactly as it sounds, it's what you see happening, so what you observe. So if you see a color change or bubbles being produced, if you feel heat being produced, if you could smell an odor, those are all observations. Okay? So based on your observations, it will lead you to a deduction. So a deduction is what you can deduce or conclude based on your observations. So for example, if your observation is that there are bubbles produced in the test tube, we can deduce based on that the substance is reacted to produce a gas. So we're going to look at observations and deductions. So today we're going to do 8 different experiments to see if there's a reaction being produced or not by looking at our observations. So we have a number of different solutions here, and they're all labeled with letters. So of course we don't know what they are because they're unknown solutions. So as I mentioned in the first video, if there's any time you're working with a solution that is labeled as an unknown, you want to make sure that you treat it as a hazardous substance because we don't know what it is. Okay? So it's always important to work safely and treat everything as hazardous. So we're going to start off by mixing the solutions in test tubes. So I have 8 test tubes here for all the different reactions. So I'm going to follow along with table 2.2 in your lab manual. And what I'm going to do is take 1 test tube for each reaction, and I'm going to add 1 milliliter of the identified substance to the test tube. So we're going to start off with the first reaction, which is A plus B. So you can see that the solutions here are A and B. Both of these solutions are clear, colorless solutions. Okay. So I'm just going to take 1 milliliter of each solution and put it in my test tube. So I'm using a disposable pipette to measure out 1 milliliter. It's not exactly 1 milliliter, but it's close enough for this type of experiment. If we were doing a different experiment, we may need to use something more precise. So 1 milliliter into our test tube, and you can see that it is a clear colorless solution. So that's A. Now I'll take B. Same thing, 1 milliliter. And you can see as soon as I add it, we get a color change. So that is definite evidence of a chemical reaction. You see that it's a yellow color, and you should also be able to see that there is a precipitate being formed there. A precipitate is a solid that forms when we mix 2 liquids together. Okay? So we have a yellow solid being formed. So our observation in this case is that we have a yellow solid being formed, so 2 colorless liquids mixed together, and they produced a yellow solid product. So that's what we observe. What we can deduce based on that is that a reaction occurred between A and B that produced a yellow precipitate as one of the products. So our observations are exactly what we see. It turned yellow and formed a solid. Our deduction is that they reacted to produce that solid yellow product. So that's the difference between observation and deduction. Okay? So now we're going to do the same thing with all of the other solutions. Okay? We're going to follow along with our table again. So the next one is C plus D. And your lab manual specifically asks you to look for a smell or an odor. So again, I'm going to take 1 ml of C. And 1 milliliter of D. And this one you need to look really carefully because it happens pretty quickly. When I add it, you see that there are bubbles being produced. Okay, so our observation, formation of bubbles. What is our deduction based on that? C and D reacted to produce a gas. Now this one also asks us to smell, see if there's an odor. So how do you properly smell a test tube? You hold it close to your face. You don't stick your nose down in the test tube because sometimes we have harmful vapors being given off and it could cause damage to your nose, so don't do that. So you hold it close to your nose and you waft the vapors towards your face. I don't smell anything. Yeah, you're going to have to take my word for it. but there is no odor. So the other part of our observation in this case is that it produced a gas, but also that it produced an odorless gas. So again, our observation, we have bubbles being produced and no odor being given off. Our deduction based on that is that C and D reacted to produce a gas that was odorless. Okay? So that's that one. Okay. So our next experiment is going to be B plus C. So now we'll take B again. Again, 1 milliliter of each one. Again, B is clear and colorless, as is C. Okay, so you can see here, we're looking for a color change. We don't see a color change. We don't see bubbles. We don't see a solid being produced. I feel it. There's no heat being produced. So in this one, our observations are that nothing happened, nothing occurred. Our deduction based on that is that there was no reaction. So B and C did not react. Okay. Our next test is going to be A plus D. Okay, so A again, clear colorless. And D. And in this one, you can see that we have a white solid being formed. So you see that? It looks kind of milky. It's a white solid. It's somewhat of a jelly-like solid. Okay. So you can see that that's being formed there. So our observation, again, A and D reacted to produce a white precipitate. Our deduction is going to be that A and D reacted to produce a white gelatinous precipitate. Okay. So that's A and D, a white solid. The last half of our table, we've got E and F. Just move these aside so you can see. E is also a clear colorless solution. All of these are clear and colorless except for G, actually. So 1 milliliter of E and 1 milliliter of F, again, which is also clear and colorless. Wow, look at that. So this one is a purplish red color, okay? So you can see that it changed color. If you look closely, you can see that it's still clear. So it didn't actually produce a precipitate this time. There's no solid substance, it's just a color change. So our observation is that it changed color, that it turned purple or red, whatever color you want to call that. It's more of a purplish color. I can also tell from here that it has an odor. It's kind of a sweet smell. Okay, so I can smell that there's an odor being produced. So my observation are that we have a color change, we have a red color being formed, and an odor being produced. My deduction is going to be that E and F reacted to produce a reddish purple product that is soluble in water. So there's no precipitate, there's no solid being formed there. So that product, whatever that red product is, or that purple product, is soluble in the water. Okay. So that's our deductions on that one. Next test is going to be E and G. So E, again, clear colorless. And this time it's E plus G. And you can see if you look at G, that it's a little hard to see, but it's a light blue solution. So take 1 milliliter of G. Now it's still blue, but you can clearly see that it's a different color blue. So that does indicate a chemical reaction. You can also see, if you look closely, that it formed another jelly-like type solution. So it's a gelatinous precipitate. Okay? So our observation, it turned blue, produced a blue product. Okay? There's no odor, there's no heat being given off or anything else. Our deductions are going to be that E and G reacted to produce a blue gelatinous solid. So the next one we're going to do is E and H. So we take E again, which again is a clear colorless solution, and H. And again, we see no color change, no solid, no heat, no bubbles, no odor, so no change. So we can conclude based on our observations that there is no no reaction here between E and H. And finally, we have E plus I. So E again, clear colorless. That wasn't quite a mill, let's get a little bit more. And I, also clear colorless. And in this case, we don't actually see anything. We don't see a color change or bubbles, but if I feel the test tube, it is actually getting warm. Okay, so as they react, it produces heat. So you're just gonna have to take my word for it. But the test tube is warm, okay? So our observation that the test tube became warm, our deduction will be that E and I reacted to produce heat. So that's our deduction based on our observation. So that's it for part A of experiment 2. We'll be back in the next video with part B of experiment 2. Thanks. Hi everyone, it's Judy here again, and today we are going to do part B of experiment 2 in Chemistry 1100, which is the identification of a substance. So a common problem that chemists encounter is identifying an unknown substance. So an unknown in chemistry is a substance which has an unidentified, so we don't know its identity. So one way we can try to find the identity of an unknown substance is by comparing it to substances that we know the identity of. So what we're going to look at today is 6 common substances, and then we're going to test them and look at their chemical and physical properties. And then we're going to take an unknown substance, an unidentified sample that we know is one of those 6 that we tested. And by comparing the properties of the unknown sample to the known samples that we have already tested, we should be able to identify that unknown substance. So the substances that we're using here today, we're going to start by looking at their physical properties. So we're going to start with salt. So this is just common table salt, the same salt you would use at home. So we're going to start by looking at the color and the particle type. So color, we're looking at whether it's white or whether it's colorless. So if you just look at a tablespoon of salt, which is about what we have here, if you look at it as a group, it looks like it's probably white. But if you focus in on an individual crystal, and you should see some there at the edges that have separated out, you should be able to see that the crystal itself is actually colorless. So you can see through it. There's no color and it's transparent. So we would say that salt is a colorless substance. It's also important to make the difference here between clear and colorless. Just because something is clear does not necessarily mean it's colorless. When we think of clear, it means you can see through it. So if you think of something like apple juice, maybe as an example, filtered apple juice, it's clear in that you can see through it, but it still has a color. So it will be clear, but not colorless. So when we look at these crystals here now, we can see that salt is clear and colorless. So it's a colorless substance. Okay, so it's not white, even though as a group it looks white. When we're looking at describing the color, we're going to look at an individual crystal. So salt is colorless. Let's move on to our next substance here. The next one is sugar. And again, you might think the same as you would think with salt, that well, it looks white. But again, if you focus in on an individual crystal, there we go, you should be able to see that a crystal is actually colorless. So sugar, like salt, is actually colorless. Our next substance now is chalk. So this is just powdered chalk, the same chalk you would see in a classroom. And this one looks white as well. So if we focus in on chalk, chalk is actually more of a powder, not a crystal substance. So like the other ones, you can see individual crystals. With the chalk, you don't really see the same crystal structure. And that's because chalk is a powder. Okay, so chalk, if we look at particle type, it's powder, where the other two were crystals. So chalk is actually white, okay, because we look at an individual piece of that powdered substance, it is white. It's not colorless like the other ones. I know that's probably a little hard to see in this video, but it is actually a white substance. Let's move on to our next substance, which is Epsom salts. And again, it's a crystal structure. There we go. So you can see, and this one is actually a little easier to see perhaps, that you can see that the individual crystals of that Epsom salts are colorless. So again, it's a crystal particle type, and it is colorless. Our fifth compound is sal ammoniac. You may not have heard of this before, but it's commonly used in cleaning compounds. It contains ammonia. If we focus in again on a crystal of sal ammoniac, you can see that it is also colorless. So it's colorless and it's a crystal particle type. And finally, we have washing soda. If we look at washing soda, we can see again here that it is just move it around a bit, it is a crystal, and the individual crystals are colorless. Okay, so that covers the colors. We've looked at the color of all of them. They were all colorless with the exception of chalk, which was white. And we can see that most of them were crystals, again with the exception of chalk that was powder. So the next physical property we're going to look at is the effect of heat. So we're going to take those same 6 samples in test tubes. So I already have them distributed out in the small test tubes. So just a small amount of the sample. Your textbooks or your lab manual says use about a pea-size amount. So that's about the right amount we want there. We're going to heat them directly in the Bunsen burner flame. So the first thing we have to do is light our Bunsen burner. And if you remember from the video on lighting a Bunsen burner, we have to open the gas valve about a full turn, open the air again to let some air into the flame, check that our lighter works. This one works good. So now we're ready to light the flame. We're opening our gas valve so that it's parallel to the hose. And there we go. Our flame lit. It's a little high, so I'm going to turn it down a little bit. So to adjust the height of the flame, we use the gas control valve. And if you remember again from our first video, the most effective flame for heating is a mainly blue flame with just a flicker of yellow at the tip. Okay, so when we put our samples in the flame, I'm going to put them in the position that is most effective for heating, if you remember from the previous video, which is at the tip of that inner blue cone. So I'm going to use a test tube holder here to hold on to the test tubes, because of course I don't want to put my hands in the flame. So I'm just going to take the sample, and the first one is salt. I'm going to hold it in the flame. Now this one, we may not see anything happening, but we might hear something. So listen closely. Do you hear that? It's kind of like Rice Krispies. So it's making a crackling sound. You may also be able to see some of the crystals jumping around in there. So salt doesn't actually burn, but it does have an effect under heat in that it makes a crackling sound. So that's going to be our observations in this case. That when salt is heated, it crackles, makes a crackling sound. So we'll let that one cool. Our next sample is sugar. We'll do the same thing again. So it's a white crystal. You can see that it's starting to melt. There's a vapor being given off, some white smoke, and it's turning brown. So if you know anything about sugar and cooking, you may know that it caramelizes when it's heated. That's what's happening here. It's turning brown, almost black. It's giving off a brownish color vapor, and that will continue until all of the sugar is completely melted. So it melts, it turns brown, it gives off smoke, and that smoke actually has a sweet smell. It's kind of like the smell of roasting marshmallows over a campfire, which is the smell of burning sugar, of course. There we go. So that's our sugar. Put this one down and let it cool. Next one is chalk. So let's see if there's any effect of putting chalk in the flame. Okay. So with chalk, we don't really see anything happening. There's no vapors, there's no bubbling, there's no sound, there's no smell. So for chalk, there is no effect to putting chalk in the flame. So no effect of heat on chalk. Next we have Epsom salts. Another white crystal, colorless crystal. Now this one you can hear a sound again. It's giving off steam, so you see that condensation at the mouth of the test tube, or at the top of the test tube? That's from water vapor being given off, so it's giving off steam. There's liquid forming around the outside edge, or the inside surface of the test tube. So you see that vapor being given off, that's steam. And if I take it out, you can see that the substance on the bottom has actually solidified. Okay? So it gives off steam, it produces a liquid vapor, and it turns into a solid residue at the bottom. So that's Epsom salts. Next we have sal ammoniac. So that was another colorless crystal. I'll put this one in the flame. So you can see a vapor being formed. It gives off a white vapor, so it's a little different than the Epsom salts. It's not steam, it's not liquid, it's a white vapor. So that's our sal ammoniac, so it gives off a white vapor. And finally, we have our washing soda. Let's put that one in the flame. Let's let it heat up, and you should be able to see some condensation forming, similar to like we saw with the Epsom salts. So it's also giving off steam. So it's giving off steam. It's similar to the Epsom salts, but we don't get as much steam being given off as we saw with the Epsom salts, but we still do get some condensation forming and some steam being given off. And the solid again at the bottom has sort of solidified. So we have a solid residue at the bottom of the test tube and steam being released. The next property we're going to look at is the effect of adding water, and what we're really looking at here is just if it's soluble or insoluble. So if it dissolves in the water, that tells us that it's soluble. If it doesn't dissolve, then it's insoluble. Okay, so we're really just looking at two things, soluble or insoluble. So I have new samples of each of our substances in test tubes again. So I'm just going to add about a milliliter of water to each one. We're just going to give it a little bit of shake. So the first one is salt, and you probably already know the answer to this one, if salt dissolves in water or not. And we can see that as I'm shaking it, it is pretty much all dissolving. There's a little bit down in the bottom. If I add a little bit more water, it should be able to dissolve all of it. But oh, there we go. It's all dissolved. So you can see that we don't see the salt anymore. It's all dissolved in the water, so that means that it is soluble. Our next sample, sugar. And again, you probably already know the answer to this one as well, if sugar dissolves in water or not. See, it's dissolving pretty quickly as I shake it. And there we go, it's all dissolved. So yes, sugar is soluble in water. Our next sample is chalk. And again, maybe you know the answer to this one, maybe you don't. Let's see, is chalk soluble in water? So it looks like it dispersed a little bit when I added the water, but if I just let it sit here, you can see that it's starting to settle out. It's falling back down to the bottom of the test tube. Okay? So that tells us that it is insoluble, meaning that it does not dissolve in water. So chalk is insoluble. Our next sample is Epsom salts. Add some water. Let's see if it dissolves. So I shake it. A little bit stuck to the bottom. And there we go. Sometimes to shake a test tube, you just kind of flick it on the bottom with your finger. It creates a little vortex in there. Helps it to dissolve. Then you can see that, yes, Epsom salts is also soluble in water. Continuing on with sal ammoniac. Water to that one again. Give it a little shake. Since this is commonly used as a cleaning compound, it makes sense that it should be soluble in water. And there you go, you can see that it's all dissolved, so it is soluble. And finally, we have washing soda, also used for washing or cleaning, so we would maybe predict that it's soluble in water. Shake it again. You can see that it is mostly dissolving. Just a couple particles there on the bottom. There you go, it's dissolved. So washing soda, again, is soluble. So of our 6 compounds, 5 were soluble. The only one that was insoluble was chalk. So the next property we're going to look at is the effect of adding an acid. And our acid in this case is going to be vinegar, which is 5% acetic acid. Okay, so we're going to add vinegar to the solutions. And I can actually add the vinegar to the same substances that I already put water in, because water won't have any effect on whether or not it reacts with the vinegar. Okay, so I'm going to take my pipette again and add some vinegar. And let's see if we see anything happening with the first substance, which is salt. And we don't see anything. So that means there is no reaction, there is no effect of adding acid to salt. Let's try our next substance, which is sugar. Sugar and vinegar. Those bubbles are just from me mixing it together. But do we see any actual bubbles being produced in the solution? No. So there is also no effect of acid on sugar. So no effect there. Let's take our next substance, which is our chalk. And before I do that, I'm just going to pour off a little bit of that water. This is called decanting, where you just pour off the water without allowing the substance at the bottom to come out. So I have a little less water in there. And again, I'm going to add the vinegar. Do you see anything happening here? Might be a little hard to see. But you should see some bubbles being formed there where the chalk on the bottom meets the vinegar that I just put in there. Do you see those little bubbles popping up? So that means it's producing a gas. So the effect of adding vinegar to chalk is that it produces a gas, so it bubbles. I remember in our observation and deduction section, we looked at observations, meaning what we actually see. So in this case, we see bubbles. Our deduction is that they reacted to produce a gas. So that's chalk. Now we're going to move on to Epsom salts. Add a little bit of our vinegar. But we don't need very much vinegar generally to get a reaction. And do we see anything there? No. So that's no reaction, okay, no effect of adding vinegar to Epsom salts. Let's move along to our next compound, our sal ammoniac. Add our vinegar again. Let's give it a little mix. And once again, no effect. So there's no reaction between vinegar and sal ammoniac. And finally, we will take our washing soda and we'll add vinegar to it. And look at that. Right away, you see it's fizzy. Kind of looks like a carbonated drink. And that's the bubbles being produced from the reaction with the washing soda and the vinegar. You might be able to hear a little bit of fizziness too. So that's a reaction. So production of bubbles means a gas has been formed. So to sum that up, we had no reaction for most of our substances. We did get a gas being produced with chalk, and we also got a gas being produced with washing soda. So now we are going to look at identifying the unknown substance. So I mentioned in the beginning that part of chemistry is commonly trying to identify a substance that you don't know the identity of. So we've tested 6 substances. I do know that our unknown is one of those 6 substances. So we're going to take our unknown sample. In this case, it's just labeled C. So again, we don't know what it is. So we're going to do all those same tests that we did on the other substances with our unknown substance. So the first thing that we did with the other ones was look at a sample of it, see what its color and its particle type is. Okay. So we can tell that it's white or looks white, like we did with the others. Let's focus in on a crystal and see if we can see if it's white or if it's colorless. And it looks like it's white. Okay, so we'll make a note that it is a white powdery substance. Okay, so we do know based on our results that there was only one substance that was white and powdery, but again, they all did look very similar. So even though we can maybe guess what it might be based on its physical appearance, because they all look so similar, and if you just sort of scan quickly over the other substances, we can see that they all look very similar, right? So even though we might think, well, we can tell them apart just by looking at them, it's probably not good to rely on that as a method for identification. So we're going to do the other tests as well that we did with the other solutions. Okay? So I have some of that sample, that unknown sample, measured out in a test tube ready to go. So the first thing that we did is heat it over the flame. So let's do that again. Again, a small pea-sized amount. And let's see if there's any effect of heat. And so far, I don't see any effect. We'll just give it a couple more seconds. So I don't see anything happening. So I think we can conclude that there is no effect of heat on this unknown substance. So far we have a white powder with no effect from heat. So if you follow along with the results that you recorded from your known samples, it looks like it's chalk so far, okay? Because we had a powder, it's white, no effect of heat. So far those results correlate with what we got for chalk. So just to determine if that's actually correct, we will take a sample and dissolve it in water as well, so see if it's soluble. So let's take our water again. We'll add some water to it. Let's see if it dissolves. Give it a little shake. And as we saw with the chalk, it's not actually dissolving, it's just settling again to the bottom. So this test would also confirm that it looks to be chalk. Okay, so not soluble in water, so insoluble. And finally, we'll take the acid, vinegar, and we will add vinegar to our sample of our unknown. And you can see we have bubbles. Move this way so you can see. There we go. So we have bubbles. We have a gas being produced. Okay. So if we look at all of those results and compare them to our previous results, if you look at of the previous 6 compounds that you tested, which of those showed no reaction with heat, insoluble in water, and bubbles with vinegar? And the only one that had all of those results, as well as being white and a powder, is chalk. So we can identify our unknown sample. C, in this case, is chalk. So that's how we identify unknowns. One method of identifying an unknown. We may look at some other methods later on, but that's one method we can use for identifying an unknown substance. So that concludes experiment 2 of Chemistry 1100. We'll see you back again here later with experiment 3. Thanks.